Okay, so we're going to check out in the intermediate value theorem, and this is our first theorem that we're going to talk about. And AP has a very interesting way of testing these things, so I'll talk about that as we go along. So first I just want you to think of something. Let's consider if I told you 3, 1 and 5, -2 are on f of x. Must f of x have a 0 between 3 and 5? So think about that and see if you would say yes or no. And hopefully you would say, well, not necessarily, because I could go through the point 3, 1. Let's just call that 3, 1. I won't label, it's not important. I'll label the x values, that's 3. And then 5, -2 is down here. Does f of x have to have a 0? You say, well, I could draw a graph. I mean, it could go like this and like this, or some other cases where it wouldn't have to have a 0. But if I said that if I added the condition that f of x was continuous and it went through these points, could you connect those 2 points without crossing the x-axis? I mean, if I threw in continuity in there, meaning I couldn't lift up my pen, could I connect this dot and this dot without crossing the x-axis? And of course that answer is no. I'd have to at least cross it one time. And this value is going to be the c value that we're talking about. Now there could be more than one, because I could certainly I could connect those 2 points and go wee, wee, wee. I mean, I had 3 points there. So there could be a great number of c values, but you're guaranteed at least one. So here's what you have to do with theorems. You have to memorize the conditions. And so one condition is that if f of x is continuous, I'm going to go to a different color, I like red better. If f of x is continuous on the closed interval a to b. If you know that. Now there's a second condition. And the second condition is that k, you give me a constant between the two endpoints. So let me write it and I'll show you what I mean. K is any value, I don't know if I'm going to write this small, but between f of a and f of b. What does that mean? Well, here I'll stick with this example and say this. Let me redraw my graph. If I have this and I have these 2 points here and here, and I tell you it's continuous. Notice I was asking, is there a 0? So does the y value have to be 0? I didn't have to say 0. I could have said, does there have to be a y value of 1? Excuse me, let me not say 1. Let me say y value of -1. And you'd say, well, if that's at -2, then yeah, I'd have to cross that. Could I say a y value of -1/2? Yes. Now if I said, if f of x is continuous, and can you guarantee me there's a y value of 4, which this was at 1? Well, you can't guarantee me a y value of 4 because I could connect those without crossing up here. So that's what that means. K is any value between the y values of the endpoints. Then what has to be true? Then there must be at least one c in AB. Notice the closed brackets, such that f of c is equal to k. Okay? That's what the intermediate value theorem says. If f of x is continuous on the closed interval a to b, and k is any y, is going to be a y value between the y values of the endpoints, then there must be at least one c in AB. This is an x value, such that f of c is equal to k. And so there's our picture. Again, you have a continuous function. You give me any y value between this f of a and f of b. In this case, there were 3. okay? This picture, I'm going to change that to k. If you give me any y value between f of a and f of b, I promise there's an x value that's going to give you that y value. That's what the intermediate value theorem says. So let's see how these problems are asked. All right, so let's look at this next one. And notice, and there's something that you need to change have on your notes if it hasn't already been changed. This needs to be a -6, by the way, down here. Okay, let's go. Consider the function, verify that the IVT applies to the function on that interval, and find the value of c that is guaranteed by the theorem. So part A, you have to restate the conditions. Now continuity you can look at and see that it's continuous. I'm going to wait to write it, but I am going to check out the second condition. And the second condition is I have to make sure that this y value is between the y values of the endpoints. So the first thing I like to do is I like to find f of -2 and f of 3. Now you don't have to write more than that. Besides, when you get the numbers, like you can plug them in your head. So you can do that and go 4 plus 12 plus 2 is 18. And you can just write that. If you're the type that needs to write more, so you just like to see it, so you do this, by all means do that as well. Either one is fine, and you get those two values. And you can see that, sweet, -6 is between the -7 and 18. So you have to state that, and you have to write that out. So here's what it looks like. Since f of x is continuous on -2 to 3, and you will need to write that interval, and -6 is between -7 and 18. Notice I don't just put those numbers without labeling what they are. Okay, then the IVT applies. So you have now proven that it applies. Now, what does Part B say? Part B says, okay, find the value of c guaranteed by the theorem. Well, what does the theorem say? Since my conditions are met, it says there has to be an x value in this interval that gives you this as its y value. That's what the theorem is saying. So what do you think you're going to do to solve that? You're going to set your equation equal to the y value that it was asking you about. So I'm going to pop that over. Plus 8 is equal to 0. And I am going to solve x minus 4 and x minus 2. And I get x equals 4 and 2. And so I have two places where that is true. Now, wait a minute. Wait a minute. What does the question say? Find the value of c that is guaranteed by the theorem. The only value of c that is guaranteed by the theorem, friends, it has to be in this interval. So I'm not saying you did the wrong algebraic thing. Does 4 give you a y value of -6? Yes, it does. But that's not the c that's guaranteed by the theorem. So you have to make sure that this number is in the interval. If there's more than one, then by all means you put it. You can have two answers for c, but they have to be in the interval. So you have to remember that. So you try the second one. You see if you can do example 2 and then come back to the video and watch. Okay, let's look at this one. Same directions, so let's look at it. Let's go through our steps. I am going to find f of -2 and f of -2. That's not a too hard one. -4, that's going to be -4. And f of 27, kind of a weird number, but all right. 27 minus 2 is 25. 27 plus 3 is 30. And so that is, I mean, I can reduce if I want, or I can leave it alone. I might need to reduce just because I'm like, okay, I wrote that way. I wrote that as 0.8. So it might, be helpful for me to write that and simplify that fraction, or to write this as a fraction. So whatever, this would be, of course, 8 over 10, which would be 24 over 30. That might be helpful if you weren't sure, like, is it between there or is it not? So you kind of have to make sure that it is. Don't just assume that it is, because it may not be. And if it's not, if they ask you, because on these questions it says verify that it does apply, but some questions might say, see if the IVT applies. If one of the conditions isn't met, then no C is guaranteed, because you just say that the conditions aren't met. So I do have to be careful and not assume that it's going to be between the values, but this one is. Now, this question is this continuous? Well, that's not a continuous function. Where is it discontinuous? It is discontinuous at x equals 3, negative 3. But is that a big deal? No, because negative 3 is not in your interval. So I'm not saying the function has to be continuous everywhere. It has to be continuous on the interval you're talking about, and this one is. So again, I write, since f of x is, and you can abbreviate, continuous on the closed interval negative 2 to 27. And 24 over 30, which is that, is between negative 4, certainly bigger than the negative, and less than 25 over 30. The IVT applies. Now let's get our part B. Our part B says find the value of C. So I'm going to set my equation equal to my y value. Now you certainly could set it to 0.8. I don't want to really deal with decimals, so I'm going to write that. I could do 8 over 10, I could do 24 over 30, but I'm going to do the smallest numbers possible, so I'm going to do 4 over 5, and then I'm going to do the algebra to get my answers. So I'm going to cross multiply 4x plus 12 is equal to 5x minus 10, and I would get x equals 22. And is 22 in my interval? I mean, if it's the only answer I got, I better have it right because I'm guaranteed 1. So yes, my C value is 22, and that is in the interval that I needed. So that's what you'll be doing on several questions of your homework, is finding those things. Remember, if either of the condition, but in your homework, there might be some that the theorem does not apply. So if they don't apply, you tell why it doesn't apply. Tell me the condition that is not met. This last one is a good example as well. Whoa, that got tiny. Of a multiple choice, how they kind of test this on AP. And so let's read it. It says the function is continuous on the closed interval and has values that are given. The equation f of x equals 1/2 must have at least 2 solutions in the interval 0 to 2 if k is what? Now I'm a picture person. If I run across a question that I don't really understand or going, what are they saying? I draw it out. So I'm going to draw a little picture. I know it goes through the point 0, 1. So here's 1. I know my function goes through 2, 2. So boom, boom. It goes through here. And what is the question asking? Half the time, these questions, if you figure out what they're asking, that's kind of half the battle. It says the equation f of x equals 1/2 must have 2 solutions. So if I drew f of x equals 1/2, that would be there. Must have 2 solutions if k is one of the following. So I'm asking, okay, the y value at this point 1. And I have to cross that line. Well, geez, that's silly. I mean, if I put a dot up here at 3, am I going to cross that green line twice? No. You can probably eliminate 2 for the same reason. It would be there, because that was 2, remember? I don't cross that green line twice. What about 1? Nope. Nope. What about 1/2? If it was 1/2, would I? Must have at least 2 solutions. Must have. So if this is 1/2, I could draw this where all those are true, but I wouldn't have 2 solutions. The only one that is left, or that makes sense to me, is this one. Because if this value was right here, and I had to connect those 3 dots, I would have to cross that green line at least twice. So that would be my correct answer. So that's what you will be doing this evening. You will be working on the IVT.